Kia ora. I'd just like to first acknowledge the iwi of the Hauraki Gulf. Thank you for allowing us to all enjoy this beautiful place. And also to Dave, my amazing supervisor, who is just, yeah, thank you. Wherever you are, there you are. And thanks for introducing. I'm going to start talking a little bit about some of the research that I've been doing for my PhD. What I've been looking at is how seabirds recover to islands following predator eradication. So Dave's given us a really nice introduction about some of the things that the island ecosystems, the ecosystem engineering properties of seabirds and how they can start to recover following predator eradication. I'm going to take it in a little bit of a different direction. I'm going to talk about some of the other factors outside of island conservation that we maybe need to start thinking about for the future conservation of the islands here in the Hauraki Gulf. So yeah, Dave talked about those ecosystem engineering properties. And we've kind of alluded to the fact that seabirds are marine animals and they spend most of their lives out in the open ocean. I do imagine that if they emitted carbon dioxide, then perhaps we would be in a little bit more trouble for climate change. But unfortunately they don't. But they do. Come on. You can do it. They are exposed to a lot of human activities and the pressures that we put on the oceans at sea. So plastic pollution is revealing itself to be an incredibly big issue for a lot of marine creatures, not just seabirds, but whales and turtles, some of the species that actually frequent the Hauraki Gulf here as well. Fisheries bycatch, that's obviously a huge issue, as Glenn's just talked about, and it's going to continue to be an issue as the population increases and we demand more fisheries resources. Climate change is a bit of an elephant in the room. We don't really know what the impacts of climate change are going to be for our seabirds, but there is potential for it to shift prey distributions and foraging opportunities for seabirds, so, which could also mean positive impacts, and that's definitely worth more investigation in the research community. And these threats don't operate in isolation. A species isn't exposed to just one. They're often exposed to multiple at the same time, and so this antagonistic relationship can have really significant impacts on populations and population growth. Now the orange arrows in this figure are negative and the blue are positive, so there again are some positive impacts from fisheries discard. Some species have been found to increase their reproductive output and their body condition so that breeding is much better. The dashed lines are just dealing with chicks and eggs and fledglings, and I'm actually not really going to talk about that too much. What I'm going to talk about, my research is focused on adult survival, so the breeding members of a population. And as you can see, it's not exactly straightforward, it's quite complex, and there's a lot of feedback loops going on in this, on the impacts of marine threats to seabirds. So, where do I need to point? I need to point over that way. One of the questions for my PhD is how do these marine threats interact and then affect seabird population recovery once we take predators off the islands? And we're in a really unique position here in New Zealand to really take some novel approaches to investigating this question. So I'm going to share with you some of my science, because science is amazing. This is what gets me out of bed every day. I love it. It's amazing, an amazing thing to be able to do every day. And yeah, I would do that, but I've just put my back out a little bit. So many of you might be familiar with this figure. It's a population growth curve. So it's a pretty standard theory in ecology or in population ecology that you have a number of individuals, and as they reproduce, they can grow at an intrinsic growth rate, or the maximum growth rate for that population, which is limited only by their reproductive output, how many offspring they have, and the age of maturity. Once you get up to K, which is carrying capacity, then it flips and resources start limiting the population. And so what we expect when, what we expect when we have rats on an island is that the population is suppressed, so it never reaches that intrinsic population growth rate. It stays down below. When we take predators off the islands, my thumb's not strong enough. What we see is that sorry, there we go, that the population can actually grow at this intrinsic population growth rate. We've taken away that predation pressure, and so we want to, or we assume that the seabirds on the islands out here in the Gulf are at this point in population recovery. They're moving at a really nice high trajectory. I'm not going to go into too much details about the statistics because it's taken me about 3 years to actually get my head around it, and trying to explain that in 1 minute is quite hard, and everybody's eyes tend to glaze over when you start saying statistical models and demographic population growth and things like that. So no Mr. Beans here today, please. Oh, you're going backwards now. There we go. Really struggling with that one. So we took our 14 species of Priscillaria forms that we have here in the Hauraki Gulf, beautiful range of species. We'll talk about 27, but I focused on these our petrels and shearwaters, and I created population growth curves for them. So intrinsic population growth, the maximum growth that they could grow after predators have been taken off the island in the absence of any other type of pressure. And as expected, what we found is that their population trajectories are all positive. Seabirds have naturally low intrinsic population growth rates because of their long lifespans and their low reproductive output. But they range from about 2.5% per annum to 15% given the population sizes that are here in the Hauraki Gulf. And then what we did... Okay. And then what we did is we used a perturbation analysis. So we affected adult survival rates, or we took out some of those breeding adults from these threats. So essentially we just killed some birds due to plastic pollution, fisheries and climate change. And we did that based on empirical data that we'd taken from a bunch of research that has been done around the world and here in New Zealand. Climate change was a bit more of an educated guess, but please forgive me on that one. And what we found was that fisheries bycatch, just individually without any of the other threats, sends most of our species into decline. So it pushes their population growth curve below zero, which is not good news. It means that the long-term trajectory of that species is going to go down, and we're going to have to figure out what to do about that. Plastic ingestion, we had a bit more variable results, and that's because different species are more or less likely to ingest plastic. We're still trying to ask those questions and answer those questions about why one species is more susceptible than another. Come on. Climate change. Oh, it's got a delay on it there. Climate change, again, we had variable responses, and this is a little bit arbitrary in the sense that we don't really know how these populations are going to respond, but even if we take a tiny, tiny fraction, less than 1% of the breeding population out because of climate change related issues, it does push those populations into decline, or some of them. What's, I guess, concerning is that when we combine these threats, it pushes most of them down below that 0 point. So 0 is going to be stable, and anything below is not good news. And these are over a year. And I also want to point out that these are very conservative estimates. So we're taking very small numbers of individuals out of that adult breeding population to get these kind of results. And part of the reason for that is because they have small populations already. So what does it all mean? It means that we can't ignore the threats at sea. We can't ignore these big ambiguous kind of things that we can't necessarily quantify that well. We need to start thinking about that in terms of conservation and future conservation of seabirds in the region. How can we manage these threats? Well, we need to actually ground truth this. We need to know more about how these threats might be affecting populations on the ground. So we need more research and we need more monitoring, and the Northern New Zealand Seabird Trust is doing a lot of work in that area, and you're going to hear a lot more about that later this afternoon. And by doing this and using models like the ones that I've created here, we can prioritise which species might actually benefit from additional management actions. How can we buffer these species from, or these particular at-risk species from being affected by these threats? At an individual level, we can reduce our own impact. We can reduce the amount of plastic that might be going into the ocean. We can advocate for other people in our community to use less plastic. We can choose better fish, use the Forest and Bird for Best Fish Guide, which is, and find those species that have are less likely to be caught in certain types of fisheries. Climate change, again, big elephant in the room. All we can do there is really lobby our government. So fortunately we have an election coming up pretty soon, so we can vote for the party that is going to make the biggest change towards improving our status on climate change. And that's it really. Thank you. Whakawhitai.